Welcome to Dhivys Techycom. In this video, we are going to discuss about waveform distortion. There are two different types of waveform distortion. The first type is frequency distortion and the second type is delay distortion. In this video, we are going to discuss all these three topics in detail. Let's get started. Waveform distortion is found to be the first major problem in transmission lines. The definition of waveform distortion is when the received signal is not the exact replica of the transmitted signal, then the signal is said to be distorted. So every one of us know we have a transmitter part. Assume this diagram to be the transmitter and you will have the receiver. The main idea of the transmission system is to send a information signal to the receiver, and the sent information signal has to be perfectly received by the receiver. But if when there is a waveform distortion, the signal that you transfer from the transmitter will never will be in an exact change received by the receiver, which means the output waveform will be in a different shape. So you have to take care of this distortion only at the receiver part. Why? Because in the receiver part only we'll be analyzing whether the transmitted signal is exactly received or not. So the definition says that the received signal, if it is not the exact replica of the transmitted signal, we come to a conclusion that the waveform has been distorted. So as I've told you, there are two different types of distortion. The first distortion is frequency or attenuation distortion. So from the name itself, we can conclude that it is something related to the parameter called alpha. And the second distortion is called as delay or phase distortion, where it has been related to the parameter called beta. So you know how does the wave propagation can be represented. See, the wave propagation gamma can be represented as alpha plus j beta. So each of these parameters will be contributing for one different types of distortion. So let us just discuss one by one. So let us first discuss about frequency distortion. So frequency distortion is like when the signal transmitted is not equally attenuated. For example, assume you have a voice signal. Okay, you have voice signal. Generally, voice will consist of frequencies like F1, F2, like you'll have till Fn we have. All these individually frequencies will have an individual alpha parameter. Why? Because they will be attenuating at different sets of values. Like frequency 1 will be attenuated at different alpha and frequency 2 will be attenuated at different alpha. So you have transmitted signal will not be equally attenuated. You cannot come to a conclusion that all these alpha are equal. Why? Because there are depending upon different sets of frequency. So in this case, if the signal transmitted is not equally attenuated, then the received signal at the receiver part will never be the exact replica of the transmitted signal. So we want each of these frequency components to get equally attenuated, which is highly not possible with the transmission signal. I mean, without any types of equalizers or any other stuffs, you cannot directly come to a conclusion that they'll be the exact replica. Okay, they'll never be equally attenuated. So this is a very famous equation of alpha. This is a very general equation as well, that you can find this equation after learning the general solution of transmission line. Okay, so after deriving the general solution of transmission line, this alpha equation will be given. So all these alpha terms, you can identify this, they are dependent on omega. So when you talk about omega will be equal to 2 pi f. So omega will be equal to 2 pi f. So what does it mean? What we can infer from this part is the attenuation constant is some or the other way depend on the frequency. Okay, so all the terms in alpha are somehow the other way being associated with frequency, which gives us an inference that the transmitted signal will never be equally attenuated. So you have to give some major attention for this frequency distortion reduction. So way you can find this frequency distortion, a major problem is when you want to transfer an audio transmission, when you want to give your voice transmitted for a very long time, for a very long distance, you find this frequency distortion to be a major problem. The second part is, how does this frequency distortion be eliminated? With the help of equalizers. Majorly, if the equalizer is giving you a high gain, then you can choose such types of equalizers, right? So frequency distortion, I told you what is the definition, the equation of general equation of alpha. How does the alpha been related with frequency, that I told you. What will be the serious problem, what it will be affecting, and then I told you the method for eliminating this frequency distortion. The second type of waveform distortion is delay distortion. So let us get to know what delay distortion is actually all about. So when the voice signal is sent to some frequency component, it will be delayed more than those of other frequencies. As I've told you in the previous example itself, let us take the same example. Let us assume we have the voice, we are going to transfer the voice signal. Okay, it will be having different sets of frequency. Each of these frequency will have different time sets. Okay, they'll be having different time sets like Tn. So what is the relationship between frequency and time? It is 1 by T. So what we can conclude is the frequency will be delayed at different parameters. Not all the frequency components of the voice will be transmitted at same time. So all the frequency components will be transmitted at different sets of time period. So we'll have the beta component. Beta is the phase constant, right? Or it will be here mentioned to be as the delay component as well. See, here you have again, it will dependent upon omega. See, when we in a very short, we'll be discussing about distortion-less line in the next video, but alpha should never be a dependent of frequency. Okay, for making your transmission line to be a distortion-less line, you should not have a frequency dependent for attenuation parameter, but beta can be linearly dependent upon frequencies, right? So that is one relaxation that you can enjoy with delay distortion. So where this delay distortion will be a big headache for us means it is in the video transmission. I can give you a real-time example that when you're watching a live cricket match in your home, the real experience, real videos that has been recorded in the auditorium or in the auditorium will be reaching you with some delay time, right? So that is one major example you can identify that delay. Okay, so video transmission. So the solution that has been given for video transmission, to overcome this delay distortion is coaxial cables. But to my point, that is not a feasible solution, right? If you want, if you see a live match happening at Bangladesh, I cannot just relay it lively with coaxial cables, right? So that is not found to be a feasible solution. That is why researchers have been keep on working on such parameters. So that is the second type of waveform distortion. I hope this video was informative enough. For further updates, stay tuned with Dhivys Techycom. Thank you.